You might come across this in your forthcoming exam. Here's exactly how to crack it. So we'll always start with our data. This is a sample from sound wave. A tuning fork vibrating at a frequency of 512 hertz. So we're just going to put our data down. The frequency is 512 hertz. Is held over the top of a jar filled with water and fitted with a tap at the bottom. If the jar is 60 centimeter, tall, this will be height. This will be our height of the jar. Height of jar 60 centimeters. Now note, we can't actually make use of 60 centimeters here, so we need to convert it straight up to meters. I'd always advise to just convert it straight up before you continue. To convert centimeters to meters, you just need to divide the value in centimeter by 100. And so if you punch in on your calculator 60 times 100, 60 divided by 100 would get 0.6 meters. 0.6 meters. They will go further. And the speed of sound is 350 meters per second. 350 meters per second. Determine the possible resonance position. Determine the possible resonance position. Now, next is to write out our relations. Write out our relation. We need to first solve for, since we're given frequency and velocity, we need to solve for wavelength. So pro tip 1, solve for wavelengths. Solve for wavelength. And in order to solve for wavelength, we'll make use of wavelength equals V over F. This is what we'll use at first. And next thing to do is to plug in our data. Wavelength equals, our velocity is 350 and our frequency is 512. So I'll just go ahead and punch the calculator. 350 divided by 512, it gives me 0.68 meters. 0.68 meters. Now, once this is gotten to be our wavelength, would now go next. We'll solve for pro tip 2. The pro tip tells us about what to do, right? Actually, pro tip 2, we solve for resonance position. Resonance position. We solve for resonance position, and the relationship that we need here, or the formula that we would use, is actually for the first resonance. So for first resonance, the formula becomes F equals lambda over 4. For second resonance, it is 3F0 equals 3 lambda over 4. For the third resonance, it is 5F0 equals 5 lambda over 4. And now we'll plug in our values into individual each of the resonance. So we are going to start with the first one. This is F naught, people. So F naught equals our lambda. We solve our lambda to be 0.68, right? 68 over 4. This gives me 0.17 meters. Next, 3 times, which is our second resonance, would be 3 times 0.68 over 4. I'll go again. Let me punch it now. 3 times 0.68. I'm getting 2.04 divided by 4. Divide by 4. And I'm getting 0.51. This is in meters. We'll go further. Say for the last one, which is the third resonance, 5 times 0.68 over 4. So 5 times 0.68, you get 3.4 over 4. So 3.4 divided by 4, you'll be getting 0.85 as our value. Next and lastly, I'm going to write out all values we've gotten. So we got 0.17 meters, comma, we also got 0.51, right, meters, and 0.85 meters. Now the possible resonance here are 0.17 and 0.51. This 0.85 is beyond it, because it is 0.85 meters, sorry, is greater than the length of the jar. Do not forget that our length of jar was given to be if you remember, I'll scroll back. We're given 60 centimeters, then we converted it to, that's the first thing we did, the length of jar, 60 centimeters, you will see there, which is this, and so we converted it to 0.6 meters. So the value the possible resonance here are 0.17 meters and 0.51 meters, which are less than 0.6 meters or 0.60 meters. But anything greater than 0.60, which is like 0.85, it's not part of the resonance because it is greater than the entire length of the jar. Now, would you like to solve similar questions as this? Click on the link in the description below. You win. Just believe.